Hello everyone. So today we are talking about PgBouncer. So I'm Euler. I work for EDB. I'm a Postgres contributor and also a PgBouncer committer. Well, after starting talking about PgBouncer, how many of you know what PgBouncer is? Oh, great. So just to introduce the topic, I bring a definition of a connection puller and why it's so important in some of architectures. So a connection puller is basically a software that will keep database connections open in order to speed up the requests. And the key point here in this case is the authentication and authorization time that might be expensive, and we want to avoid that. So basically the goals of connection puller is that we want to quickly assign Postgres connections to clients in order to run transactions as soon as possible, authenticate one for several thousands transactions, and also to reduce the transaction executant time. So that's an important point because there are some small transactions in some workloads, and authentication plays an expensive part in the time. And the second goal is that we want to kill requests if we are using a lot of connections. And in this case, instead of letting the application open indefinitely connections, we limited, and then we avoid some issues. For example, if you are open a lot of connections, maybe at some point, if you keep open connections, the scenario will be worse. So instead of doing that, we just stop opening connection, wait until the current transactions resolve, and then we can start processing the other requests. So the key point here is to avoid consuming more resources than we have. And then doing that, we throttles the resource usage and keep acceptable performance, even if we have some peaks in your application. So let's talk about the design. PgBouncer was designed to be a simple connection puller and also a lightweight one. It basically works as a transfer tool between the applications and Postgres. It speaks the Postgres protocol, of course, and the idea here is to inspect the package as fast as possible to handle the workload. It does not depend on libpq or other Postgres library, so there is no such dependency. It uses a very low memory for each connection, and it also is possible to do some online reconfiguration. So if you are changing parameters, you can just reload the service. You don't need to stop the service and start it again. And it's also possible to do some online restart, which means you restart the service without dropping client connections. So of course there is a magic behind it, but it's possible, and you keep the state of the client connections. And the HR is fine in this case. And also, because it's a simple design, it uses a single thread to do its job. If there is just one case, if you are using the PAM authentication, it creates another thread to handle the PAM authentication. If you're not using it, which means if you don't build PgBouncer with PAM support, it's just one thread. Well, we'll discuss more about these design decisions in a few slides. Well, it's written in C. There is just a few dependencies. We have mainly two dependencies, the lib event and the lib usual. Lib usual provides the infrastructure for the server code, and the lib event is an asynchronous notification library that we use to execute functions based on what the clients are sending as packets. There are some optional dependencies. For example, OpenSSL, if you are supporting SSL connections between the client and PgBouncer. It's not between PgBouncer and Postgres. It's between client and PgBouncer. PAM, if you have to cover it. Systemd, if you are integrating with the OS. And there are also some libraries if you are using DNS. So depending on what kind of DNS library you want, it basically uses the lib event support, but you might choose to use another ones, for example, Ciares, UDNS, and even glibc library. For building, we use AutoTools for Unix and MinGW for Windows. Well, the project is hosted on GitHub. So we have a bug tracking where we encourage people to provide issues for problems, and also we answer questions there. We also receive some pull requests for fixes, and there is also a website where we provide the documentation. Well, regarding the project, let's talk about the past. This project is since 2007. So the version 1.0 was released on 2007. It means the project is on the road for 16 years. It's a long time. It's not the oldest connection pooler for Postgres. If I remember correctly, PGPool is a few years old than that, but it seems it's the most popular connection pooler for Postgres. Of course, that's my opinion. Regarding the releases, we had 48 releases along the years, and we generally release 2 or 3 releases per year. That's the pace. Well, lines of code. So I checked the C lock for the lines of code. It's just the code. It's not documentation, testing, configuration, man page. No, it's just the code. PgBouncer has roughly 26,000 lines of code. So it's not too big, but it has some complexity. And just as an idea, the initial version contains almost 6,000 lines of code. So it means the project grown 4 times. So people behind the project, we had 55 contributors along the years, and we have 3 active committers. The last release was 1.19. It's small, but we had some important features here. One of them is a new parameter called outDBName. Basically, this option lets you specify which database you want to run the authentication query. For example, if you are using a version prior than this one, every time you try to authenticate a user, it will use a connection in the same database you are executing the query. So it means that sometimes if you have a lot of databases, you can have a lot of idle connections that you use to authenticate. And sometimes it's not desirable because it will take some time to close these connections, depending on how your configuration is. So this option lets you choose one database for authentication. So it's better because you keep the number of connections for authentication is small in this scenario that I mentioned. And the other point is related to the infrastructure for authentication. For example, if you use a query to authenticate, you have to create some objects. For example, you create a function and you have to grant permission for it. And in the previous case, you have to create the same object on all of the databases you want to use. But with this option, you just need to create your infrastructure just in this database. There is a new command called show state. It basically lets you know the global state of PgBouncer. Like we will talk later, we have some states that we can query PgBouncer and it reports. For example, it can be active, paused, suspended. There is a new feature called peering. It basically fixes a case when we are canceling requests. So it basically lets PgBouncer knows about when we have multiple instances and we send a cancel request for it, so it can find the exact database that you need to cancel a query. So it's a new feature. And we have another parameter to determine how long we will cancel a forward cancel request. We also overall the testing framework, so it's now written in Python, and it's better to maintain and add new test case. And there are a lot of fixes, mainly related to previous releases. And we also did some cleanups in the CI. This release was out in the past month, but we discovered two important fixes, and we decided to release a new version today. So today we released 1.19.1. So it's basically a minor version that fixes two important. Sometimes it's rare to crash, but it's important to have it available for everyone. So we decided to release a new version today. Let's talk about how PgBouncer works. So before doing that, let me provide a background. Postgres has an architecture similar to this one, but right now we are interested in this part, the backend, and the supervisor, the main process. So the Postgres architecture, it's basically a client-server model. So each connection is a backend process. And basically, when you are dealing with an application, you have three important processes. You have a client process, you have the supervisor, and you have a backend process. So when you open a connection, you have to create this backend process. And at the beginning, I said that authentication plays an important role when we are using connection pullers. So the idea here is to avoid opening and closing a lot of these backend processes. Behind the connection puller, we have a concept of pull mode. So for the connection puller, the database is a pool. And we have different pull modes. Basically, we have three pull modes: section pooling, transaction pooling, and statement pooling. In the section pooling, the Postgres connection is released after the client disconnects, which means that we have the same number of clients, roughly the same number of server processes. I can say that if you have 10 clients, you will have 10 active backends. And it supports all Postgres features. And then you have the transaction pooling. Basically, the Postgres connection is released after the transaction is finished. So in this case, you have an interesting scenario, because you can have more client connections than backend processes. And sometimes this number can be an order of thousands of connections. Of course, there are some issues because a few section-based features are not supported. And in this case, prepared statements and list and notify are not supported because it depends on the backend memory. So it's not supported. And statement pooling, basically, connection is released when you end the statement. So it's not allowed to have a multi-state transaction, or even if you start a query with a begin, it's not allowed. And the main use case for it is PL proxy. I forget to mention, but who started this project was Skype, because they have a problem with scalability and they require to have lots of client connections, and there is a limited number of resources for the backend. Well, so we have the configuration. The configuration is really simple. We have a file called PgBouncer.ini. It's an INI format, and the last version has 87 parameters. It's divided in 4 sections. We have the main section called PgBouncer. We have a section called databases that you define your pools. And you have a users section that you can provide some user settings, such as a specific pool mode for a certain user, a maximum number of user connections. And in the last release, you have the peers connection that you can set up peers to handle the cancel requests. And there is another configuration, that's the authentication file. Of course, you can decide to authenticate outside PgBouncer, but even if you decided, you need to create this file to add just maybe one user to handle the credentials for the special database called PgBouncer. So this database is an admin database for PgBouncer. We talk about it later. And this file is important for this point. If you decide to authenticate using just PgBouncer, you can. So you have to define this authentication file. You can choose a name for it. And it basically contains user and password. And the password can be plain text and also can be a hash, MD5 or a scram. PgBouncer supports some authentication types. It doesn't support all of the authentication types from Postgres, but the most important ones it supports. So it supports MD5, scram, certificates, trust, PAM, and there are 2 special authentication types. Any, that's almost the same as trust. The only difference is that trust requires that the user must exist, and any it does not check user and passwords. And of course, any is a dangerous authentication type. Don't use it, mainly because it will allow anyone to connect to the PgBouncer database, and I will mention some commands later. So anyone can run admin commands on this database. So someone can shut down your PgBouncer. So don't use this type. And there is also an HBA authenticate type. So it basically reads an HBA file with different rules, and you can use it if you need more flexibility for your authentication. So the rules are similar to an HBA file in Postgres, but there are some restrictions. I won't mention some restrictions here, but check the manual and see if everything is covered. Well, there are some pullers. I won't mention all of the configuration files, configuration options, sorry, but here is the most important ones. So there are some puller sections that you can provide some configuration. So for example, there is a general pull mode. The pull modes I mentioned earlier. So you can specify section, transaction, and statement here. It's a global setting. Of course, if you want one pull to have a different pull mode, you can. You have just to specify in the pull which pull mode you want. There is a server reset query parameter that basically runs this query after you release the connection. So basically, if you want to reset the section before you reusing that connection with another client. There is an ignore startup parameters. Maybe you want to ignore some Postgres parameters. Server fast close if you need to immediately close a server connection that is in close needed state. A stats period, stats are sent to logs from time to time, so you can configure it here. Max number of client connections, it's the same concept as max connections in Postgres. So you can limit the maximum number of client connections in PgBouncer. Default pool size, it's a default pool size for all of the pools. Of course, you can decide to use a different pool size for each pool. Minimal pool size, a minimal number of connections that will be there for a pool. A reserve pool size, it's a concept. For example, if you are using all of the pool connections that you defined, even if you try to use a new connection, but there is no slot available, it waits for server reserve pool timeout seconds, and if even after that you can't get a connection, PgBouncer will give you a connection from this reserve pool size. And you can also limit the number of database connections, and also the user connections. There are some timeout settings. Server life timeout is a time that you close server connection because you want to avoid a leak or something like that. So it provides this setting for you. Server idle timeout. When the connection is idle, after this time, PgBouncer will close the server connection. Timeout for connect. A time for retry the login because you can't log in, and also a timeout for query. Use it with parsimony because you can start canceling queries and sometimes it's not desirable. And also a query wait timeout. It's basically if there is no connection available in the pool, it will wait until this time before canceling the query. And there is the cancel wait timeout that I mentioned that's available in the 1.19. And there is also some timeouts for the client connections. So I can close client idle timeout, use client idle timeout to close connections that's idle in the client side, and also for login. And the last one here is the idle transaction timeout. So if I have a connection that is idle in transaction for a certain period of time, PgBouncer can cancel it. So when I'm dealing with PgBouncer, I need a way to execute some commands to handle some cases. So we have admin commands for handle certain tasks. So for example, PgBouncer provides a pause command. Basically, it disconnects all of the backend connections, and it will wait until all of the queries are finished. And after that, the command will return. So it waits until all of the queries are resolved, and then the command returns. New client connections will wait, will be in the queue. It's until we execute another command called resume. It's really useful for a database restart. So we retain the client connections, restart the database, and then resume. And for the application, it seems nothing happens.
If you're using transaction pooling mode or another pooling mode, will it wait for the whole transaction to close out before?
Yes. Yes. So the concept here is the same depending on your pool mode. For example, if you are using section pool mode, it will wait until the client disconnect, release the resource. And the transaction, of course, it wait until the transaction ends. And the statement will wait until the statement ends. You have disable and enable. Basically, reject new client connections and then can resume with the enable command. And all of these commands, you can see there is a DB. So for example, you can do it per pool. DB means pool here. There is a suspend. It's a command that flushes the network buffers, and then new client connections will wait until we resume. And resume work for all of these commands, kill, that I will mention in the next slide, pause, and suspend. So kill, the idea is to immediately close client and server connections because, I don't know, you need to close client connections and server connections to do something, I don't know, any task, and it will resume once you execute the resume command. The reconnect, it can be important in some cases. For example, when you are doing some reconfiguration because a switchover, you need to execute a switchover and change some connection strings. So it can be used, or you can also change the connection string and use reload. So it can also be done. And wait close, it's another command that wait until all of the server connections has changed to a special state called close needed. And in this case, this command is useful when you are using the reconnect, or also the other approach that's similar to it that I mentioned, when you change the connection string and you reload. So wait close can guarantee you don't have connections that are sending data to 2 points when you're doing a switchover. So if you have a switchover routine, you have to make sure that you execute reconnect, and after that the wait close command to avoid reading or writing in 2 different points because of you are executing a switchover. And you have a reload command that reloads the configuration file. And there is also a shutdown command that just exit the PgBouncer service. Of course, some of these commands you can use some signals in the OS, but you can choose to use just the commands. It's easier to use SQL to execute commands. And talking about monitoring, you have some show commands that can present some data and stats for PgBouncer. So you can obtain the list of clients, servers, some information about each pool you have, and what kind of mode you have. Show databases also provide some information about each pool. Show users provide information about users, peers. This new feature that I mentioned, it provides some information about it. I mentioned just one stat here, but there is also other stat commands that aggregate some data. So that's stats total, stats aggregate, that provides some stats for you. There's a command for lists because the way that PgBouncer was, the concept behind PgBouncer is based on lists. So when we are dealing with if a connection is in use or not, it uses lists and it moves each server or client connections between these lists. And there is a show state that I mentioned before that provides a state for PgBouncer, and there is also a config that lists all of the configuration parameters. And there are other commands that I didn't mention here. As an example of show pools, one of the main commands here, you have several important information here. And for example, you can diagnose problems based on this data. For example, if you look at the CL weighting, you can see the 70 there. What this number means, it means that there are some client that's waiting for a backend connection. So it can indicate that you probably don't have a lot of server connections available for this pool. And if you have this number for a long time, it means you have to reconsider your configuration. And there are also information about cancel requests. You can also check how many servers you have available in idle state or in login process. And here you can see how many time you are waiting for backend server. And databases, you can see information about pool, such as the connection string, part, database name, pool size, reserve pool, which pool mode. In this case, there is no pool mode here, so it's using the default and the current connections and the state of the pool. If the pool is paused, if it's disabled. Based on that information, when you are executing the admin command. And this is the new command called show state. So it's a global state that can indicate if PgBouncer is available. In this case, it is active, or if it's paused or suspended. Well, so let's talk about a roadmap. We have some ideas in the community. And the first one, the number one request is prepared statements in transaction pooling mode. As I mentioned before, it's not supported in the transaction pooling mode. And why this feature is so important? Basically because some scenarios, you have some cases when you have dozens of thousands of client connections and you need just a few server connections to handle the workload. So right now, if you need prepared statements, you have to run PgBouncer in section pooling mode. But the disadvantage is that you need more server connections to handle it. Basically, you have a lot of idle connections on Postgres, and sometimes it's not good. Of course, Postgres handles it better now after a few releases, but even though you are wasting memory maintaining such idle connections there. So we have an in progress patch for it, and hopefully we can get this feature soon. I can't promise which version, but let's hope it's soon. The other feature that's in process is to support LDAP authentication type. As I said, if you need LDAP authentication, you need to use PAM, and you have to do a setup for it. And sometimes it's not desirable. If you can support the LDAP here, it's good. Basically, the same way that we set up LDAP for Postgres. And we are also working on a feature to be FIPS compliant. Basically, it needs to not use MD5 when we are dealing with SSL connections. So basically, this feature involves the libusual. That's the library that provides OpenSSL support for PgBouncer. And there is a node bug in PgBouncer since the user section was introduced. It basically described it as multiple enters for the same user. As I mentioned, PgBouncer works with lists, and in this case, depending if you are using this feature users, it creates multiple entries for the same user. And depending on your scenario, you have an issue with it because it does not get the right user. Because, depending on your configuration, it's just a user. It can be from different pools, and you can have some confusion related to it. So we have to fix it somehow. Like I mentioned about SSL, we are planning to overhaul the OpenSSL support because it's too old. It's using API from a previous OpenSSL, and some functions is in deprecation mode, so we have to change that. Some additional per pool settings, and also it would be good to support GSS API authentication type. Sometimes it's desirable. And the last point is multi-thread. So a lot of people mention that is not using PgBouncer because PgBouncer is not multi-thread, and because they have some issues regarding CPU usage and are limited for a single thread. It's like I mentioned, PgBouncer was designed to be simple, and when you are changing this design for a multi-thread design, you are adding complexity, and sometimes it's not desirable. So what PgBouncer did was to implement a way to handle this issue. So it basically has a parameter called SO reuse port. This parameter basically uses a kernel infrastructure that allows you to use the same address, the same port on the same host to handle different servers. And internally, the kernel chooses which instance they send the information. So if you are using this, you can create multiple instances of PgBouncer on the same host, and each instance will use one CPU. So you can solve this issue when you are handling a lot of connections and you are hitting the CPU usage issue. And of course, we are open for suggestions. There are a lot of ideas. I just mentioned some of the most popular ideas here. And that's it. Questions?
I saw previously that SO reuse port was turned off for the CentOS PgBouncer packages. Do you know if that's been changed and that's on by default now?
I'm not aware of that. I have to check why. But sometimes, as I mentioned, it's for any specific scenario. The overall scenario, one thread is okay, one instance is okay, but for some cases you need multiple instances of PGBouncer. But I have to check why. I don't know.
It was a pretty old article, so it could be stale information. So.
Okay. Anyone else?
Do you also do any work with PgBouncer for data wrap?
Yeah, I didn't mention it. One of the I was thinking about it. You basically need it because there is no way to do some joins when you are using the commands. So when I show these commands, there is no way to execute some joins here. So sometimes you need to compare the clients and servers to see which client is connecting in which backend, and sometimes it's hard. So people generally use PGBouncer FDW to handle this case. Maybe we can create additional commands here to handle this case, to provide the join.
What about integration with secret stores like HashiCorp, Vault, or anything else?
I'm not aware of any integration with it. Any questions? So we are ending here. If you want, I'm available during the event. We can discuss anything about PGBouncer. Thanks.